Welcome to our demo for P.I.E. P.I.E stands for Personalized Interactive Education. Our mobile application targets to help connect student to instructor and student to student during and outside of classes. Instructors are able to check on student attendance during class sessions and keep tabs of each class they are lecturing for the semester. Students are able to ask questions and provide feedback for the professor on their lectures and overall teaching. Starting this discussion between instructors and students will greatly improve the overall learning experience.
When you open the Pi app, you will get to the signing screen. From signing screen, you will see a sign in button. Once you click on the sign in button, it will ask user to put their Gmail account. Once you sign in with your Scarlet Mail, it will lead you to the next screen where you will be signed in to your account. From there, it will retrieve your name and Gmail profile picture of the account that you're signed in with.
First, we'll be looking at the instructor side of the app. This is the home screen that they'll see once they've logged in as an instructor. They'll be able to see all of the classes that they've created within the class list. And in the bottom left is a microphone icon. When they click this, they'll be able to access the accessibility tools, which Kenny and Keen will talk about later on. They fully implemented this functionality, but it hasn't yet been integrated with the UI. So once the instructor clicks add class, they'll be prompted with this modal where they can enter the class name and class ID. The class ID is unique to each class, and it's what we will use to identify the class when a student tries to join it. The instructor can add as many classes as they like. They just have to make sure to have a unique class ID for each new class. As you can see, pressing on each class within the class list takes you to its respective class info page. So going into the software engineering class, the instructor can add times, location, professor, and TAs for that class. So once you click update, you get an alert that the class info has been updated. But when you try to update it with a field missing, you get an alert that all the fields are required. At the bottom, there are three options for navigation. You can either go to home, which you could also achieve by pressing the back button, but the home button provides a little more user efficiency because they can see where it's taking them. They can go to start session, which is where the instructor will press if they want to start a live session in order to take attendance from the lecture attendees. And they can go to past sessions where they can see past sessions that they've completed. Clicking on Start Session, we're navigated to this screen. At the top, it says Live Session in the header, and underneath it, there's the name of the class that you've selected, along with the words Live Session. Underneath, there'll be a running count of the total number of students that have joined. And in this view, you can see the name and NetID headers at the top. Once our servers and database are connected, we'll be able to connect between instructors and students, and this will show a live list of the students that have joined this particular session while it's active.
If the instructor would like to view student feedback that they have received, they should navigate to the past sessions screen where they can find the previous session feedback button.
Going into the student side of the app, we see a similar homepage with options to join a class or create a study group. Pressing join class, we see this modal where the student will enter the name of the class as well as the unique ID that was assigned to this class by the instructor. Going into the class, we see all of the information that was uploaded on the instructor side relevant to this class, as well as an option to join session. Once the student clicks join session, they're prompted with this modal where they will upload a photo of themselves, and once the facial recognition portion of our project is integrated with the UI, this will be a check for the student's attendance. Underneath the Join Session button, we see the Preview Student Feedback Form button. Once we have the capability to host live sessions, at the end of each one of them, the student will have to fill out a feedback form in order to count as attended for that session. So this button shows a preview of what that will look like once the live sessions are in place. We see two fields, subject and feedback. If we try to submit without filling out these fields, we get this alert. So it is mandatory for the student to fill this out in order to be marked as attended.
In order for the instructors to have ease of access to student-provided feedback, our feedback functionality features a sorted list and a word cloud, which were developed using the natural language toolkit libraries in Python. In order to create a sorted list of feedback for the instructor to view, student feedback data will be extracted from the database into a text file that will be used for performing noun phrase chunking, providing the key phrases that will be used in the sorting algorithm. As you can see on the left side, I have a text file with sample student feedback to the instructor. Upon executing the program phrases, we can see that the noun phrases from the sample feedback have been listed. These will be used to sort all the feedback the instructor receives into categories for efficiency. To give the instructor a general idea of the feedback the class is providing, a word cloud will be generated displaying the most frequently occurring words in large text in the center and lesser occurring words smaller towards the edges. On the left side, I have a text file with sample feedback from students to their favorite professors. Upon running the program cloud, we are able to see the generated word cloud and the very positive words highlighted, such as passion, inspired, favorite, learning, memorable, and all this will go to facilitate the instructor's understanding of the student feedback.
In order to verify one's attendance, the first step is confirming their facial recognition. So in order to do that, we use OpenFace, which is a Python and Torch-based toolkit that implements deep neural networks for the purposes of facial recognition. So basically, it takes two input images and then compares all their facial features and then returns a floating point number, which determines whether or not the two faces belong to the same person or not. And the threshold for that number is 1. So if the number is greater than 1, then the two faces did not match. But if the result is less than 1, then the faces do match and it's the same person. So the attendance can be verified. To demonstrate this, I have 3 images, 2 of which are of Obama and 1 of which is of Trump. So notice how Obama, even with glasses, if I run these 2 images, the result should be less than 1. And if I run an Obama image compared to a Trump image, the result should be greater than 1. So let's test that out. Looking at the OpenFace library, we can see a lot of Python functions, but the only one we are concerned with is compare.py. So I will show an example of how to run compare.py. Let me first try a picture of Obama and compare it to Trump. And theoretically, of course, the value should be greater than 1, which it is confirmed here is 1.5. But now if I compare the 2 images of Obama, the result should be less than 1. And it is 0.859. So our theory is confirmed with the actual OpenFace results. Now, in order to test the OpenFace functionality with Pi, I first decided to create a very basic UI app that allows the user to take an image, upload it to our server here at AWS, and then run OpenFace and return the result back to the user. So in order to do that, I just start my server here, and then it'll wait for a client connection to happen. Also, please note that any inputted image will be compared with this image of myself. Just for reference, the first image, which I compared Beyonce to myself, had a result of 1.16, which unfortunately implies that I am not Beyonce. But the image of where I compared my face to whatever's in the database was 0.275, which confirms that it is a match.
Hello, my name is Park. As you've just heard from Priya and Ryan, the authentication use case of our application has 2 aspects: facial recognition, which they cover, and NFC authentication, which is what I will be covering. So here with me I have an NFC tag, an Android device. This is a 1+1 from 2013 running Android Marshmallow. And I also have Android Studio open. So I'll run the build, and in the meanwhile I'll explain the functionality that we have. The core functionality that I will be showcasing in this demo is the ability to utilize the hardware of both Android and iOS devices to use their NFC scanners to read and write NFC tags. NFC tags come in an encoding called NDEF, so our application is not only able to read but decode NDEF, and not only able to write but encode NDEF onto these tags. Now, this is important functionality that we have made progress on, and I'll explain what its importance is and what is left to be done. So, the app has finished building, and here it is, P.I.E NFC test, read NFC and write NFC. So this is a blank NFC tag, so first let's write to it. So I'll click write NFC tag, add record, media type, key, and payload. Let's create a dummy key, ABC 1, 2, 3, okay. So now we'll click write to tag, scan the tag you would like to write to, and so we'll hold the tag behind the phone, and there it is. It has been written to the tag. Now we'll go to read NFC. Here we'll toggle the scan, and we'll hold the NFC tag to it, and boom. If you look on Android Studio, right on the bottom, it says, read end of message with one record. Now this is important because our application is able to extract the data on the tag, so type key with payload and data of ABC123. So, this is important for NFC authentication because what we're trying to build is a decentralized authentication system without worrying about student abuse or student overwrite of tags. Now, normally, a student could easily read a tag and send that tag to a friend if there was just a single static tag being passed around in the classroom. And that would defeat the purpose of this authentication system. So what we have in place, the algorithm that we've put in place, is a decentralized peer-to-peer re-authentication system where student 1 will read the tag and the application will then send the data or the key on the tag to the server. The server will verify that. If the server does verify it, it authenticates that student as being present in lecture. But that's not only it. Then the student's app will generate the next key, send that to the database, and write that on the tag. So now that previous key that they just scanned is stale, and the next key is now the active key for the session. Through the system, we will mitigate any sort of abuse to the system and be able to verify that a student is present in the lecture hall. Thank you. So the only real remaining functionality needed to be implemented for this use case to be fully flushed out is hash or key generation, as well as server-side or back-end authentication, which we'll just cross-reference with our database to verify whether the key is the valid key for this session or not.
Welcome to the TTS and STT portion of Pi. Here we will demonstrate the main functions and benefits of having a text-to-speech and a speech-to-text accessibility tool integrated within our app. First, allow me to explain the buttons. For this demo to activate speech-to-text, you'll need to press the Enable button and then the Start button, which will allow you to speak to the system. Inside of this mode, you'll be able to speak into the phone and your text will appear inside of the top black box so you can verify that all your statements were captured correctly. Inside of the recorded history portion will contain your previous speech-to-text inputs. When you're done speaking, you can stop or cancel with the two buttons to the left at the bottom, or after a few seconds of silence, it will cancel automatically. Another important feature of this app is the command mode, which can be activated from the sidebar or via speech input. Turn on command mode. This command mode allows you to access a bunch of functions such as clear history, change the view, or open the sidebar. This command mode also connects with the text-to-speech portion of our app, which can be activated by the Read Screen button.
Title is TTS and STT Demo. Recorded history, commands available. Clear history. Open sidebar. Change theme. Light mode. Dark mode. Help. TTS. Read screen. Read header. Read history. Read all buttons. Turn off command mode. Command, help. Command, open sidebar. Command, change theme. Command, light mode. Command, dark mode. Last voice input. Command, red screen. Body buttons are circular red clear button. Circular gray enable button. Bottom buttons are dark cancel button, dark stop button, blue read screen button, blue start button. Title is TTS and STT Demo. Recorded history. Command, clear history.
Hi, my name is Ryan Davis, and I'm going to be showcasing some of the back-end functionalities of our application. On the left, you will see an application to test these functionalities, and on the right, you will see the output of our running server. So first, I'm going to log in. Then we have the image signup. This sends an image to our server, where we extract the feature data from the image and save it inside the user's profile. Up next, we have the image sign-in. This will compare the picture I take with the feature data already stored in my profile. Then it will determine if the picture I took contains the same face that is stored in my profile and notify me if I was able to sign in. And as you can see, I was able to sign in. Now we have the add class function. This simply adds a class to our database. Then we have the create session function, which creates a new attendance session for the specified class. Then we have the add feedback function, which allows the user to submit feedback regarding the current session. Then we have the create group session, which allows the user to create a group study session where they can specify the time, place, duration, and any person that they want to invite. Last, we have the report issue function, which allows a user to submit an issue report about our application itself. And that is it.
As you can see from this demo, there is still a lot of work to be done to integrate all the features into one cohesive application. On the instructor's end, we need to tie together the student feedback inputs to an efficient instructor feedback view and implement live session connections between instructors through the server. On the student's end, we need to enable student feedback responses to be written and submitted while also allowing study group hosting and maintaining lists of all student course information in the application. Once all these functionalities are fully implemented, we will rigorously test for optimal application functioning. Thank you for listening. We hope you enjoyed.